So a subset of this set I would be piano. That's a small subset, but it's a subset because it's a smaller portion of the bigger set I. So the set I just drew here is a subset of I. Here's another subset. I'm only thinking of instruments that are a part of set I. So that means this is a subset of set I. It's a smaller portion of I. So if you see the words subset, and if you see also the terminology proper subset, a proper subset means it's smaller than I, it's not equal to it. But if you just see, if they're asking for just subsets and not proper subsets, that means you could have the entire set I, piano. I'm going to write that out. Here, piano, flute, violin, guitar, trumpet, saxophone, cello, harmonica. Okay, the set I just wrote is a subset of set I. It's the exact same thing, actually. All the elements here are in set I, but this would not be considered a proper subset. Okay, so the exact same copy, it's considered a subset, but we just say it's not a proper subset. A proper subset is a subset that's a little bit smaller, like the ones I put up here. Okay, so obviously that could take a long time, right? I've only done 2 so far. You could do piano flute, piano violin, piano guitar, piano trumpet, piano saxophone, piano cello. So there's a way quicker way of doing that. The formula for proper subsets, it's 2 to the power of n minus 1, where n is the number of elements, okay, in the set. So in this set I, we have 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sets. So 2 to the 8th minus 1. And if you want to do that in your calculator, you could use the exponent key. You could type 2, then hit the exponent key, and then hit 8. And then subtract it by 1. So there's 255. Or if you don't know how to do the exponent key, 2 to the 8th just means 2 times 2 times 2 times 2 times 2. Oh wait, that's 5. Here it's 6, 7, 8. Here, let me write it out the whole way. 2, 3, 4, 5, 6, 7, 8. It's 2 multiplied to itself 8 times. And then we have to subtract 1 because they said proper subsets. Okay, if it said how many subsets, it's almost the same thing. It's just 2 to the n. This is for proper. This is for proper up here. And this is for when it's just asking how many subsets are there. Okay, so let me show you with another example. And this one I think is smaller. We can actually even count them out to make sure. So how many subsets and proper subsets does this have? Look, there's 3 elements. So the number of subsets is 2 to the 3rd. So there's 8. How many proper subsets? It's 2 to the 3rd minus 1. So 2 times 2 times 2 makes 8, minus 1 makes 7. So there's 8 subsets, 7 proper subsets for this one. And you could list them. Okay, here's it'll be easier for you to type it. This one's small enough so we can see them. Here, this set I just wrote, that's a subset of M. It uses only the elements of M to create a new set. This is also a subset of M. It's pretty small, just one element, but still a subset. So here we'll do all the pairs. And then, I'm missing some. 1, 2, 3. One, 2, 3, 4, 5, 6. What am I missing here? 1, 2. I've got 6 sets, but there should be a 7th one. I just don't know. Oh, the empty set. I forgot about that weird rule. So the empty set is always a subset of set M or any other set that you're talking about. Okay, and that's kind of weird, but that means if you were trying to make a smaller set out of the group of M elements, you could just take nothing out of it, and that counts as a set. So that's the 7th one. So look, these are all proper subsets because they're all created out of set M. 1, 2, 3. 1, 2, 1, 3, 2, 3. I've created those all from M, and none of them are exactly the same. So this is the list of all proper subsets. But if you wanted all subsets, itself is itself is its own subset.